So inside of our, hello everybody, welcome to our class, but inside of our CCNP on INARSI class, I did put the instructor lab source files. So if you're doing the troubleshooting labs and you can't figure out why you're not able to, something's wrong or you can't figure out what the error is, I put those in there so that you can go in and look at the instructor labs themselves. So if you'll download this, this is every single lab with the instructions. Yes, Brian, go ahead.
Hey, one of the things, can you hear me okay?
Yeah, I got you. What's up?
One of the things I've found with the troubleshooting labs is that if you just do the first ticket and don't reload them, just run the configuration scripts again for the second ticket, they work just fine.
Really?
Yeah. So the only one I had an issue with, the only one I had an issue with, I think it was maybe the BGP one or something, or no, it was something on OSPF where it left like a stub area configuration in it, but I went in and took it out and it was fine.
Right.
So.
Well, you might, and that may be true, but to be absolutely sure, you do need to erase them. But like I said, if it's working, it's working. I mean, you know, if that works for you, that's great.
And also, when I put the configuration files in the Word document, I only put the configuration files for the stuff that I changed.
Right.
Because there were, on every ticket, there was like 3 routers you didn't do anything with.
Exactly. So there was no need to put, there's no need to put anything in there that you didn't do anything from. I agree completely. So if you don't change the router, don't bother with putting it into the thing. Does that make sense, Clayton and Brian?
Yeah, I haven't done any of the troubleshooting. I've been trying to get ahead in the reading, and and I think I'm going to start doing the labs probably tomorrow or the next day. I think I can catch up with the labs because reading and going over it over and over again, it really helps. Yeah, it's gonna really help because
some of the troubleshooting labs are honestly just like, really. I mean, it's very. I mean, some of the stuff you're just like, you can figure it out by just looking at the config that you paste in. You're like, well, there's the error. So
well, that's what I thought about the first lab.
Yeah, some of them are very, very simple.
Yeah.
So you just have to kind of be careful with that you don't let yourself get, just don't overthink it because some of them are super simple.
And one more question I was going to email to you is about if you have a OSPF network with I'm gonna say 4 routers, a backbone, and 2 areas, and an autonomous system border router. The way that LSAs are transported from area to area, from area border router to area border router, and from autonomous system border router in. When we were very young, we knew that the Type 7 turns into a Type 5. But how does that LSA transport through the stub, not so stubby and stub areas?
Okay, well, first off, it's not going to transport through a not so stubby or stubby area because stubby areas don't have a transport capability.
Yeah, okay. But stub areas, correct me if I'm wrong, it's one way in and one way out.
Correct. So they're not transit. Nothing transits a stub.
Oh, transit. Transit was the wrong word. Okay.
Okay. Are you talking about exiting the stub?
Yes.
Okay. Well, let's spend a little bit of time talking about LSAs first off. So let's look at our different LSAs. Now this is a 76 slide PowerPoint, so we're not going to get through it all today. Brian, did you have another question? You still got your hand up. I just want to make sure I get you. No, okay.
No, I'm good, thanks.
All right. So let's start out with the easy ones. Type 1 LSA is where each router describes its configured networks on its links. Okay. Type 2 LSAs are used in a multi-access network by DRs and BDRs, but basically the DR takes the type 1s, converts them to type 2s, and sends them out to everyone. So you won't even see type 2s unless you've got a broadcast segment. So it's got to be something that's Ethernet or broadcast based. Type 3 are the LSAs that go between between networks. So it goes between area border routers. So type 1 or type 2 information that comes into an area border router gets converted to a type 3 and then gets sent to other areas because it's a summary address of everything. Now, that's where people sometimes get confused. Just because you break OSPF into different networks or different areas doesn't mean that by default, everything is not advertised throughout the entire network, because every single type 1 or type 2 does become a type 3 summary if you don't do something to make it a smaller routing table. So just be aware of that. Now, still, a bounced interface on a router will have less effect on the rest of the network, but it will be advertised eventually throughout a type 3 LSA. The type 4 ASBR is used to locate the ASBR if it's in a different area than the area a router sits in. So basically it's an LSA to say, how do I get to the autonomous system border router? And then type 5 are those that are external. So when we see an EX or external OSPF route, it's something that's been redistributed into OSPF, like the default route when we do our OSPF default information originate. And then type 7 are for external network prefixes that are redistributed into a local NSSA. Now remember, by default, NSSAs are really just one way. Not stubby areas try to go, they have one way out. It's almost like a default route out other than, and no way back in, so to speak. They don't get all the routes from the other areas. They're just, they keep up with just a way out. There's other types of LSAs too. They're not telling you about all of them. So if you do more reading and find out about other LSA types, there are other ones. But let's run down and just do a quick look at some of these. Now, first off, again, remember, it is flooded. These LSAs are flooded. Type 1 stay inside of an area. They do not leave an area. Type 1 and type 2 don't leave an area. They are only inside for the routers that are part of an area itself. You will not even see a type 2 unless you've got a multi-access network. So in this case here, you'll notice our example network of 1, 2, 3, 4 has an Ethernet segment on it. So you're going to have type 2 LSAs inside of there used by the designated router to convert type 1s to type 2s and then send those out to all of the routers inside of the area. Now the border router, in this case R4, will then take that information that it gets and change that to a type 3 to send it to other areas. Okay. Now, one of the things I do want to talk about a little bit here is, see if I can find where it was at. Okay. It is important to kind of think about this, and that is if a type 3 LSA is created from a type 1 LSA, the total path metric to reach the originating router in the type 1 LSA is the metric. But if it's a type 3 that is created from a type 3 LSA from the area 0, it's the total path metric plus the original path cost. So let's look at this down here. If you look at the metric down here and you look at type 3 LSAs, R4's perspective of the type 3 LSA created by the area border router 5 for 10.56.1.0. So if you look here at R4, okay, so area 0, it is going to have a cost of 1 to get to this type 3 LSA created by R5. All right, because it's coming from area 56 into area 0. If it's the other way, if it's coming from area 0 into another area, and it's whatever metric comes in with it is added to the metric of the type 3 LSA. So if it comes into R3 here, R3 would have actually a 67 metric for the 10.56.1.0.
So that makes it an E2, Kelly?
It would not be an E2. No, it would not be an external route. It would not be external because type 3s are not external. They're not redistributed. Okay, that would be a type 5 that's an E2. Only type 5s are external, not type 3s.
Okay.
Type 3s are still from within your areas in your OSPF network. Type 5 are those that come in externally. So these are the ones that come in from either redistributed via static, like your default route, redistributed from another interior gateway protocol, or just being redistributed.
I've always had problems with this. So if you have an external network and you're redistributing into an autonomous system border router. That is a type 7 that's going to be converted to a type 5 that's going to be propagated throughout the network. Is that correct?
It's not necessarily, no, it's not a type 7. It's just a type 5. Because it's coming in, it's not coming in from a not so stubby or a stub area. It's coming in from some other routing source.
Okay, so if I redistribute RIP into my OSPF,
there you go.
Yeah, that's going to be a type 7, right?
No, that's going to be a type 5.
That's going to be a type 5.
That is a type 5. Yep. Because it's an external.
Okay.
Yep. We'll get type 7 here in a minute, but that's a type 5. Where we see this most often is with redistributing the default route into OSPF. That's where we see it all the time. But we also do redistribute other routing protocols into OSPF and other static routes into OSPF. Okay. So here we can see the type 5 LSA. If you do show IP OSPF database external, it will show you the external network number, external route, what network it's for, the metric that come in with it. All of that is a type 5 LSA. Okay. Now, type 4 just gets you to your ASBR. That's if you're not in the same network as the ASBR, it's a network, it's a route that gets you to the ASBR, so you know how to get to it. Otherwise, you wouldn't know how to get to the autonomous system border router. That's what a type 4 is. Now, type 7 only exists in NSSA. Okay. Now, again, it's not a type 5. It's a type 7 coming in. Now, let's see what they've done here. Well, this entire network, this is not a smart way to do a network. Let me see what they've done here. I see where you're getting confused.
Okay, help me, please.
Type 5. Okay, let me keep looking. All right, well, here it is. So it is a redistribution, but it's a redistribution within that NSSA, which is, you really shouldn't even be doing that anyway.
But that's not allowed.
Yeah. And that's the only place it's going to exist is in this not so stubby area. It's going to come in as a type 7 when you're redistributing something. I don't understand why they put the
That's very confusing to me.
Yeah, I don't know why they put the autonomous system or an ASBR inside of a not so stubby area. That is a very weird network design. All right, let's look at it, but it's an edge case scenario, so it's going to be on the test. So
it is going to be on it?
Oh yeah, I would guarantee it's on the test because of the fact that it's an edge case scenario that nobody would really do in the real world. So they're gonna try to catch you on it. So let's just memorize it and then not design our networks like this. But basically, got not so stubby area, which is a stubby area is supposed to be an area that nothing else comes into, and it's just one way in, one way out. That's it. But a not so stubby area, for some reason, you are bringing in external routes into a stubby area. So it's not a stubby area anymore. It's a not so stubby area. Very poor network design, but in that case, you would get a type 7 LSA, and because that comes into an NSSA and it is in an area border router, will see the type 7 and there is no understanding of a type 7 anywhere outside of an NSSA. It will have to convert it to a type 5 LSA, which is an external one. So it's going to make it look like an external route. And it's also going to, you'll notice, it not only sends it to the autonomous system border router, it sends a type 5 for external, but then it also will mark R5 as an autonomous system border router. You'll see this type 4 here. So if the type 5 cross area 0, the second ABR creates a type 4 LSA for the type 5 LSA. So you'll notice, even though this may not actually be the autonomous system border router on R6, because there's an external route in this network, R5 is being seen as an autonomous system border router. And that is why this type 4 has to come into area 1, 2, 3, 4. Because that tells R1 and R2 how to get to this external route for this ASBR, which is on R5. What do we got in chat here? Hold on a second. All right, Nicholas. The type 5 normal comes from the edge of the network from the internet. Right, but could become. Yeah, now Nicholas, you are correct. You could get a type 5 from another protocol, yes. Main campus have default routers. Satellite campus will still have a default route out to the internet where it's physically closer to them rather than use the default route. Okay, let me think through this one, Nicholas. So what you're saying is you're saying that you've got your satellite campuses have their own internet connection, and they also have a connection back to the main campus's internet connection. Is that what you're saying? And if you got a mic, you can come off. If not, just type it in. So you're saying that your main campuses, it's a private metro back. Okay, well, let me think a minute. So you're doing split tunneling then. So you're allowing traffic that is not destined for the local or not destined for the campus, main campus, to go back out on its own instead of being routed back into the campus network. All right, let me think about that if that would be a good way to do. Yeah, that could be a possible use for this. We don't allow our traffic to split tunnel. We only allow our traffic to come back. Okay, let me ask you this. How are you controlling, and if I need to turn off recording, let me know. If you don't, well, you're on chat, so it's not really being recorded. How are you controlling security for that non-tunnel traffic? So the traffic that's not coming back to the main campus. I know, I wish you did too. It'd make it a lot easier, but that's okay. The traffic coming back to the main campus usually goes to the firewall on the main campus. So you've got an additional firewall on each satellite site that is basically replicating the campus security policies. Is that correct? If that is true, then this is a possible use for you. Yeah, you are correct. A private circuit, okay. Then I don't think it's not a use case for you then, because what's not happening then, I'm gonna do a quick picture. We're gonna take a little aside here, folks, and see we'll see if we can figure this out. I'm not gonna promise you I'm right, because I'm not an absolute expert on all network design, but I'm gonna show you what I think we've got, what we're discussing here. And I think we're doing the same thing you're doing. But let's imagine, okay, so we've got a campus network. So here's right here. Okay, well, you are split tunneling then. Okay, so you've got your main campus network. I'm just going to do this here. I'm going to say this is the campus area network, so CAN. And there's a router sitting here. And here's your satellite campus. And you've got a router sitting here. And there's a private circuit between these two. So we'll just say this is a PC or private circuit between those two. However, this satellite campus also has a link out to the internet. So let's say this is the internet over here. I'm just going to draw a big cloud. So this is the internet. And then this is your main campus. It also has an internet connection. All right. So you've got basically what's called a dual home situation. This satellite campus could go out to the internet this way or this way. And so for most traffic, it probably goes this way because it's quicker and it doesn't have to traverse the campus network. But if this link here goes down, it obviously can then go through the campus network. Yeah, now that could possibly be, this could be a not so stubby area. But here's the only thing. Here's the only reason I don't think this is a good use of a not so stubby area. This route right here, whatever it happens to be, going out the secondary route, let's call it route B. Let's call it route B. Let's call this route A. Okay, so this is route A. Well, the problem is if it's a type 7, it's still going to get turned into a type 5, remember? It gets turned into a type 5, even if it's a type 7 that comes in here. This ABR, this area border router, is going to turn into a type 5 and send it back to the main campus. So that's why I'm thinking it's not a good use, because, see, if you had that, here, basically this external would be your route B. No, it does not get filtered at the ABR. Nope. Because see, it goes to ABR and that type 7 gets converted into a type 5, which makes it then an external route. Now, here's what could happen. And this is not necessarily a negative. All right. This is not necessarily a negative in this case. Let's think about this. If, heaven forbid, okay, if you did set it up like this and that type 7 came in, was converted to a type 5, went into your main campus network. All right. You're going to have another basically type 5 that goes out this direction right here. Okay, so you're going to have one type 5 that's got a better metric for everybody on the campus. But if this broke, if this is set up this way, they should have another type 5 that would send them out to the satellite campus and use the satellite campus out. But here's the problem, and this is where things get really, really funky. Dual homed like this, in other words, your connection to the ISP, they probably are saying that only networks known to be on the satellite campus can go out route B. And on route A, any of the networks that are associated with the campus can go out route A. So if this occurred and route A routes, campus routes started going out route B, they may not be able to find their way back in. This is dual homing. And 99% of the time, the best way to fix this or to do this is with BGP, not with an interior gateway protocol.
I agree.
Because the problem becomes, how do you get back from the internet into this network? All right. So like if you've got your web servers over here, you got www and you got a web server sitting here on your campus network and a DMZ. Well, your routes from the internet are supposed to come in this direction. If all of a sudden you start coming in this way, because this route failed and you went down through the satellite, are you going to be able to get through there? It can be done. Okay, I'm not saying it cannot be done. I'm just saying I'm not certain that this would be a good use of a not so stubby area. I think we would be better off with running BGP on these two sites and using it and redistributing BGP into. Yeah, okay. I see what you're saying. All right. Yeah, without an autonomous system number, without running BGP, I don't think doing this would give you much of an advantage. I don't think it would give you a whole lot of. The problem's going to be, even if you set this up as a not so stubby and it gave an additional route to the campus to come back through in case the main route failed, you're not going to be able to get back to the campus networks. The satellite will keep working perfectly. It won't have a problem, but the campus networks, I think, would get black holed. Yeah. Yeah, if you had the ability to do true BGP in an AS, that's what we're doing here now. We actually have dual true actual connect, and it's very similar to this. In fact, it's just we're not out here. We're running full BGP, and on each side, and it's giving us a dual home. And then internally, we don't use any not so stubby stuff. We've just got multiple routes. Multiple default routes that have different administrative distance that we give them. So if one fails, it picks the other one up. Okay. But again, I'm not saying you couldn't do this. I'm just trying to think about what would if it would cause problems with your network routing, and it could possibly. I'd have to do a little more whiteboarding and a little more thinking about it. Because see, again, if we're using this as our example, I'm gonna grab something here. I'm gonna grab a snipping tool. Get my snipping sketch. Let me grab, because this, let's see, go back to my, because what this reminds me of, or what this makes me think. Okay, so what this reminds me of is basically this right now. This is your satellite campus down here, or similar to it. Okay, your area 0 though is going to be your main campus, and so somewhere at the main campus, there's a router, and we're just going to add it here. Let's add this. Let's add a router right here. Okay, that goes up to the internet. So here's the internet. Okay. So there's your default route, and this is your autonomous system border router. Okay. Now, what you've got down here is this is actually a route that also goes out to the internet. And all traffic from inside Area 55 is designed, unless it's going to the main campus, is designed to go out this because it's a faster link. It doesn't have to travel all the way across. However, you could do this. It could happen. Then you make that a not so stubby area. It gets sent over here as a type 5. But now there's actually going to be 2 type 5s coming in here because you're going to have an autonomous system border router. It would work. It would work. It wouldn't be to, obviously right now we're just doing it to a single network. It would be to the quad 0. So you would get 2 different type 5, you get 2 different external routes that were basically default routes. And this one, the one going out this way, should have a better metric for all traffic until this fails, and then it would try to go out this way. My only caveat and worry is, can the traffic for the main network that is accustomed to going out this main line, can it get back in this way and get to where it needs to go? And I don't know. That's true. The metric may not be considered as a type 2 external. You're correct there too. Boy, yeah. I'd have to set it up and play with it. I'd have to actually build it and see what metrics would give me. I think we could honestly, yeah, I agree. I think we could honestly build it to where traffic would flow out one way or the other, based upon whether the links are up. I don't think traffic would make its way back in on a real internet. I think on the internet itself, because of the way ISPs set up their routes and traffic, I'm fairly certain, especially if you're not running BGP. If you're running BGP on those 2 external internet connections, yes, you can make it work. But without BGP, no, I don't think you can make it work. I think you'd get traffic. You'd get the traffic that left from the main campus network when this broke. It would go out, but it would try to come back in this broken link. And that link would not allow that traffic back in. And that is if you don't have BGP. Now, if you have BGP, you can actually have it flip over to this other internet link and it would come back in. So with BGP, yeah, you probably can make it work. Without BGP, nah, you're not going to make it work. I agree. And a lot of these edge case, not so stubby areas, but again, that's why it's great that you brought this up, Clayton, because this is a very edge case and it's going to show up on the exam because of the fact it is such a weird edge case. Well, I tried. I don't know if I did good explaining it or not, Nicholas. It is confusing and it's an edge case, but it is one of them. Yeah, I think labbing it would be, maybe we put it in GNS3 or CML. I do think this is an excellent little thing to look at, and that is summary of OSPF LSAs that we were talking about. Notice how each one of these inside, we've got type 1 and type 2 LSAs. Between them, we've got type 3s. And then here's an external route. We've got a type 5 coming in and type 4. So you'll notice these are the most common types, type 1 through 5. And again, that external route that comes in, it's not in a stubby area, it's in a regular area. If it had been a stubby area, it would have been a type 7 there, and it would have been converted to a type 5 coming in. But if you understand these 5, in the real world, you're going to be doing pretty good. It's going to give you a good way to kind of to look at OSPF. Let's look at a little bit at stubby areas. So they provide a method to filter out external routes and the option to block inner area routes. There are 4 types we're going to look at here. Stub area, prohibit type 5 LSAs and type 4 LSAs from entering the area at the area border router. And so the area border router generates a default route for the stub via type 3, and that's it. It gets basically a stub area gets a default route out, and that's it. And that is everything in this stub area goes over to R3. And really, there should be no other way in or out of that stub area. So we'll see here, showing the route table for R3 and R4 before it's configured as a stub, and then after configured as a stub. And you'll see that we end up with a default route that's brought in to R4 from R3, making R3 the next hop. So 1034.13, which should be this 1034.13 on R3. So stubbing, pretty easy. Totally stub, prevent type 3, type 4, and type 5. So up here, you'll notice a stub area only prevents type 4 and 5. Doesn't stop type 3s. Okay. Totally stubby stops everything, type 3, 4, and 5 from coming apart. And they advertise default route. Yep. So they basically give you a default route going out. ABR is totally stubby. I have no summary opinion configuration, so it's totally stubby. So no summary basically means block type 3s, because type 3s are summary LSAs. So the difference between making a stub area and a totally stubby area is literally no summary versus stub. But you only put that on the border. You don't put it on the other stub routers inside the area. So you don't have to put stub, no summary. Ooh, what in the world just happened? Get back down here. Sorry, y'all. So to get a totally stubby area, you don't have to put no summary on all the routers in the area. By the way, if it's just a stub, you just do stub on both, and you will get type 3s, but no type 4s, no type 5s. Totally stubby blocks everything. So no summary, no 3s, no 4s, no 5s. Now type 1s and 2s would still be taking place inside if they happen to be going on. Okay. So here we see our totally stubby area. And we should get. And then here's our really weird one. So not so stubby area prohibits type 5s from entering, but allows the redistribution into the NSSA. So not so stubby area. Then advertises it with a type 7, which gets converted to a type 5. And then also that type 5 will have a type 4 LSA that goes out as part of it. Here we see an example of basically 2 external not so stubby areas being connected, and those routes being popped into the routing table. So you notice here the area ID default information originates placed under the OSPF process on the area border router. So that makes it the border router for a not so stubby area. Okay, so this is where you thought it would get. No, it's converted. It gets converted at the area border. The default route is not injected automatically, but the default information originate does that for you. So that's why you're doing that. says not so stubby default information originate. You know, maybe if you didn't do default information originate, you could do it that way. Now that might be possible. Do area 34 not so stubby area, and don't do default information originate, and then the type 7 wouldn't be converted to a type 5. But totally not so stubby area. You know, Nicholas, that might be where you could do it. You might could do that. Area 34 not so stubby area. Leave default information originate off. Not inject environment. Well, but the problem is then they're not going to know how to get out. No one inside of this area will know how to get out of the not so stubby area unless you're bringing it in somehow else. Okay, yeah, and this is, I think here's what we're trying to do that may not be what is really the purpose of a not so stubby area. Notice how they're only trying to bring in an external route. They're not trying to bring in some type of default route to an internet connection. They're just trying to get to a network. It is assumed, and I know you're making A out of you and me when we do that, but it is assumed that somewhere else there is an area, autonomous system border area router that gets you out. We have never seen, I haven't seen anyway, a not so stubby area that tries to bring in a default route or a route to the internet. It's a route to a single network or a set of networks. So maybe that's where we're going wrong. I think it is. I think the not so stubby area is not designed to go to an internet connection. It's designed to go to a set of networks or a network. And the autonomous system border area router is still going to be somewhere else in our AS. By the way, typically the autonomous system border router should be in area 0. Not always, but typically we should probably put it in area 0. So I believe that's where we're kind of got our thinking wrong here, is we're trying to make it do something it's not designed to do. Yeah, I think that's the aha moment there, as you said. And then that, like I said, if we took this default information originate off and didn't put this on here, our stub area wouldn't know how to get out. The not so stubby area wouldn't have a way to get out, and it would not know to go to area 0 and wouldn't be able to find the autonomous system border router. So all we're trying to do with not so stubby areas is get a single route or set of routes. It could be a summary route. I mean, so don't assume it's just a single route. It could be a summary route. Brought into our OSPF. And it could be that maybe we have connected to an EIGRP network, or we've connected to some other network and we need to bring it in. So I think that's where we were kind of getting off track. All right. So notice what it does. It brings in that type 7. If you do default information originate, it will also bring in will advertise a default route out coming from R3, and then it will put out a type 5 LSA because nobody else understands a type 7 LSA unless it's a not so stubby area. And then that gets changed, also gets a type 4 LSA to get you to the external network. And if you want a totally stubby area, do no summary, that will block the type 3 LSAs, and also will make it to where you've got to get a separate, there's your redistribute. That's how you're bringing in redistribute connected networks, subnets 1. That's where it's actually bringing in those other subnets. But if you do this, you're going to have some way to get out, you're going to put it in some type of static route or a default route that is in somehow way or form passed into it. Yep. Yeah, I think that's where we were kind of getting off kilter there. Now, let me look at something just real quick. Let me look something up while we're on the, let me check something here. Yeah, I don't see. Yeah, I'm not seeing anything where those are used to, a not so stubby area is used to connect to the internet. At one time, there was actually, I think it was totally stubby networks, or a Cisco proprietary thing, but they have since been added to the RFC. Yep. Yeah, I can't. I'd do a little more looking, but I don't see anything that shows it being used to get to the internet. I could be wrong there. I just don't see any way it could work without a. If you did do that, I don't see how it could work without integrating it with BGP though. Okay. Did that help at all, Clayton?
Yes, it did.
I think the key thing for us to remember is we need to, if it's a not so stubby area, we need to realize it's going to be connected to some external network, and that external network is being brought in. And because typical areas don't understand type 7s, it has to be converted to a type 5, and then that gets sent over. And it will be seen as an external. Now, the question again I have, Nicholas, is I can't remember, and I don't think, but it will keep its metric. I think you're right. There is a way to make it keep its metric, but I cannot for the life of me remember how to make it do that. I vaguely remember at the edge of memory about how a stub area. Yeah, type 1 can do it manually, but I'll do some more and see if I can find that, because I do vaguely remember some weird command that would let you do that. Okay, well let's take a few minutes and look at our path selection. Obviously OSPF uses shortest path first, trying to find a loop-free path. The priority for paths are intra-area, so within an area, inter-area, between areas, and then external type 1, external type 2. All of these are based on cost, and remember, if you don't change the auto cost reference bandwidth by default, everything above 10 fast Ethernet to 10 gigabit will be a cost of 1. So you do need to change that, but you need to change it on every router in your entire environment if you change it. Otherwise, it will not affect all your routers, and you can end up with some really, really weird costs coming out of your environment. So external routes are classified as type 1 or type 2. Type 1 equals the redistribution metric plus the total path to the ASBR, whereas type 2 only has the redistribution metric. So that's why I'm thinking if we can get a type 1 to come in using the not so stubby area, then we would have both the cost to the ASBR, or the cost to the network and to the ASBR. You know, OSPF type 2 routes do not increment in metric regardless of the path to the metric, the ASBR. So there's a tie, it looks at the forwarding cost. So basically type 1, type 2, again, this is the total path. This is just the cost that was brought in. So regardless of how far it goes across the network, if it came in and the cost was 17, it's going to be 17 at the receiving end, even if it crossed through 4 areas. Doesn't matter. But if it's a type 1, it gets all of the cost to the ASBR plus whatever the originating redistribution metric was. Now, when you redistribute into a OSPF network, you can set the cost when it comes in. Many times, by the way, it will not redistribute if you don't set a cost. It'll just bark at you. So if you say redistribute static or redistribute subnets and you don't give it a cost, it will just ignore it. So many times you have to give it a cost. Now, OSPF can do equal cost multipathing, which means it can go across up to 4 equal cost paths by default. It cannot, OSPF cannot do unequal cost multipathing. That is only EIGRP. EIGRP has the variance command. OSPF does not have that capability. Okay. Now, regardless, the important thing is this: breaking our OSPF networks into areas allows us to make smaller routing tables. It also allows us to ensure that changes on routes or links won't have a profound effect upon our entire network. So we don't want a single link going down in an area to end up with every area across our entire environment having to do a shortest path first calculation. That would be terrible. So we can summarize using summary routes to make sure that between our areas, a link goes down. So here's an example here of 16, 1, 2, and 3 being summarized, and a metric is placed on it. So if 1.0 went down, that would not cause area 0 to run a shortest path first algorithm update. It would also not trigger another type 3 LSA coming into area 0. If we don't summarize, by default, there would be a type 3 LSA for 1.0, 2.0, and 3.0 coming from area 1 into area 0. So if 172.16.1.0 went down, area 0 would get a type 3 LSA saying it went down, and it would remove it from its route table, run shortest path first. But when we summarize, we can make it to where all 3 of the routes or all of the routes in the summary would have to go down before that would be sent across to the other routers in your network. So summarization is very important. And it's also why the way you design your OSPF network's IP addressing is super important. It's important that you put your areas into blocks of IP addresses so that you can make sure you can summarize along those area boundaries. The way we do it here on our campus is each building is its own area. And so we summarize along those areas, and we don't have to worry about, this particular building is literally 1 or 2 routes versus having, 18, 19 classrooms in the building, 19 different routes. So you want to make sure you summarize it correctly. You want to be careful with your summarization, though. You want to make sure you don't accidentally summarize things that are not in your particular area. If you do that, you can end up with some very weird items. So here we see an example of 3 different routes in the route table, and then we're going to summarize it, and we end up with a summary route instead of a set of 3 different routes. And likewise, you'll notice here we get on R2, it has a discard route to null 0, which basically says anything that's not part of the summarization, send it null 0. It goes into the bit bucket. Okay, so R3 let us summarize. Okay, so we summarized the networks coming in R3, and R2 got that summarization. Excuse me, R3 got the summarization. Now you can do the same thing with external summarization. Let's see, number at the external, yep. So if you've got, this is external coming in. So we've got external routes, multiple routes coming in. So we, instead of having all of these type 7 converted to type 5 LSAs, we create a summary on the ASBR, and it will only create one type 7 to type 5 LSA for all of those, instead of each individual one being its own route coming in. So there again is our summary address on R6, which causes it to summarize all the external routes that would come into R5. Normally R5 would have every single one of those routes, 1, 2, up to 15, down to 15. But you do the summarization, you'll notice R5 now is going to have a single OE2 to that summarized route. So you can summarize even that at a autonomous system border router if you're bringing external routes, which is good, because you may bring in more than one route. The last item I want to hit today is what's called a discontiguous network. And what this basically means is this: you are supposed to have every single network connected to area 0. If for some crazy reason, yeah, the one thing you don't, what are you talking about, the discontiguous, yeah, don't do it, first off. Don't do this, but if for some crazy reason you end up with discontiguous networks, all right, you can actually fix part of that by using virtual links, but don't do discontiguous networks. If you do this, your summarization is impossible. Plus, you've broken it because now you got multiple area 0s. There are ways to fix this, but you wouldn't do it like this. You would have a single area 0, and then you would create the virtual link between them. So in other words, what you're going to end up doing is you're going to make these two area 0s appear to be connected, and make the other areas appear to be going through and being directly connected to area 0. So area 12 will think it's connected to area 0, area 45 will, and so will area 1, 2, 3, or 2, 3, 4. Really, virtual links are more for if you've got a network over, instead of like this, it would be more for, you've got area 47 over here off of R5, and you've got a normal virtual area 0. So this is a crazy setup, but you should have like an area 47, and you can create a virtual link through area 45 to area 0. You can do this the way they're doing it here, but this is just poor network design, and I would just, it's a terrible way to design your network. Try not to do that. Now you can do it. You can do a virtual link to where you can actually link the two together so that they are, can look like they're connected, but it's a poor network design, and it's actually supposed to be only done until you can get the discontiguous networks fixed. So it's not even supposed to be a long-term solution. All right. So simplest fix is this: make sure area 0 is contiguous, and all areas are connected to area 0. Now, it could be that you did end up with area 0, and over here off of R5, you had an area 57 that didn't connect directly to area 0. That's a better use of virtual links instead of this craziness they've got here. So imagine, let me pull my back up. Imagine this type of scenario instead of what they're showing you. So let's imagine we were smart enough to do our network correctly. So we've got, we got a router here, got a router here, and this is area 0. Okay, so this is area 0 right here. Area 0. Over here is another router, and there's a bunch of routers inside here, so I'm gonna do it like this. This is area 1, area 0. This is connected over here to another router, and there's a bunch of routers in here. This is area 2. And then for whatever reason, we've got another area over here, area 3, with a router that this is connected to, and there's a router here. So area 3 is not directly connected to area 0. You could then create a virtual link that connects this area through area 2 to area 0. That's a good, decent use of area of virtual links. But still, by design, you want your areas to all be connected to area 0. So you'd want to try to figure out a way to get area 3 connected here instead of across this. Okay. So your network design is a big important thing. Now, the reason why you can't always do that is you do buy companies. Cisco completed its acquisition of Splunk today or yesterday. So sometimes you have to use these virtual links as a stopgap until you can get that connection to your area 0. All right, everybody, that is it for today. I am gone next week, so I will not be here on Monday. Actually, I'll be flying back on Monday. And I may, so what time will I get home? I get home at 1 o'clock. I don't think I'll be home in time on Monday, but I'll leave our meeting. If I can get there, I will. But I don't know what my plane is going to do. Like I said, I think I get home at 1 o'clock next. I land in Charlotte at 1, so it'd be real tough for me to be home by 4. But I'll leave the meeting on the thing, and if I can get there, I'll get there. If not, I won't be.